And here we go. Okay, so speaker down. Okay. Good morning, everybody. It's Thursday of IETF 125. I hope you found that as great so far as I did. And we're nearing the end, but now 2 hours full-packed agenda for ANIMA. So let's get started. Note well, you have actually signed that you have read and understood and are going to comply with the note well when you're registered for the IETF. So we don't need to linger here on it, but please make sure, behave professionally and follow all the other rules on it. Please, if you're in the room, log into the session anyhow, because otherwise we'll get a very, very tiny small room next time. Whichever tool you choose, full or on-site tool. Also, please contribute to the meeting notes. The agenda is the same page as the meeting notes, so that's very easy. You want to go to the agenda anyhow to see what's coming up while we're in the meeting. Quick update on the status of the ANIMA documents and what we're going to talk about here. So we've got unchanged an RFC editor cluster, C8484, with the JWS voucher, Brewski Cloud, and a non-ANIMA document that also depends on RFC 8366 BIS. So this cluster is going to be released once we finish 8366 BIS, which we're going to talk about today. Also, a Brewski PRM has a dependency against 8366 BIS, so nothing changed here on this slide. 8366 BIS, lots of work. We're going to talk about it today. The constrained Brewski solution with voucher and proxy, we're also going to talk about it. So this has gotten more attention now after we've been winding down the work on 8366 BIS between the participants. Brewski Discovery, I'm going to give an update. Constrained Grasp, there's also going to be an update. We have a part document, nothing changed on that, but the network service auto deployment has been worked on after also being on hiatus for a long time, so that's great. And then time permitting, obviously, we're going to look into a couple of new work proposals, which I'm not going to read out in detail. So let's make sure that we still do some good time tracking. And with that, I think we can move over to the first slot, which is constrained Brewski. So Esko, up to you. And do you want to have the slide yourselves, or?
Yeah, maybe first check the audio if this works.
Yep.
And then yeah, I can maybe request slides and see myself if that works. I'm not sure. I pushed the button now.
Tarlis has to stop sharing first.
Yeah.
Ah, okay.
It happened. And now, where is? Esko, okay. Yes, slide control. And I think, yeah.
So you need to unshare these slides.
Yeah. Okay. Stop. Yep. There and yeah.
No, before you pass on the slide, just do the load up the slide.
Oh, okay. Yeah. I'm not helping here.
Okay, there's the deck.
There we go.
Okay, I think I have control now. So I wanted to introduce these two drafts here. So constrained Brewski is the first one. Let's see if this works. Moving to slide 2 now. So here's a very quick recap slide, which I wanted to skip in the presentation. It's more for reference for those people who might not have seen this yet. So we're talking about constrained version of Brewski here. That's suitable for Internet of Things type of networks, for example, a 6-LoWPAN mesh network. What are the updates since last time? Well, there is a bit of new functionality defined here. So 2 changes here on the slide. So the first one is basically the introduction of the new URI path abref option. So this is an option basically being defined now in the core working group, a new option to make it possible to send a co-op request with a very short path using this new option. And the idea is to require this for the registrar so that in case a client wants to use it for the Cbrewski bootstrapping, it can use that. Yeah, the second update is that the registrar now also sends more data to the MASA. So there's text saying that it basically adds the entire pledges certificate chain. And this, well, is sometimes helpful for the MASA because you could have a minimal MASA that does not store IDF IDs for all pledges, but just stores, for example, the CA certificates for those specific pledges. And then with the certificate chain, the MASA can still check that the request is valid and is able to build the chain itself. And it's also useful for diagnostics at the MASA site, for example, in failure cases or attack cases. So this is a relatively simple change that we have discussed prior to the meeting. Okay, then I'll move to the next slide with more updates here. So there's also some content removed here. So it's actually the IDF ID issuer considerations that we have are now moved to 8366 bis. And the reason is that these considerations are applicable to all Cbrewski variants and basically also to the basic idea of the voucher, and it's not just for Cbrewski. So we decided to move that, and that's now done with updates to both drafts. And of course, some editorial changes and fixes here. Then I'll move to the next slide that basically explains the remaining open issues. So there's one issue recently added. This is something we should consider whether this is required here to add basically details for the supported cipher suites for DTLS. So there's a GitHub issue for that. So we found during work on this, or at least Michael remarked that, hey, we don't have any details on that, only basically the version that's to be used. And the current draft basically has some version requirements that are listed on the slide. So it's basically DTLS 1.3 is recommended, and there's one clear exception case where clients still can use DTLS 1.2, and the registrar must implement both, support for both. And it can also optionally be configured to accept DTLS 1.3 only. But we don't say anything about the cipher suites, basically no details there. So we do have in examples a particular combination of basically crypto parameters as shown on the slide here. And the question is, of course, here, do we need such details for DTLS? So that's the open question here. And if there are any particular views on that here, I think it would be good to add that. We can also discuss here if there's time. First, I'll just jump to the final part of the presentation. So the next steps. Well, resolve the open issue then is the next step, and wait for the dependency 8366 bis to complete. And then I'll move to the...
Can I maybe inject a quick comment?
Sure.
I think the cyber suite details will be asked for. I spent a long time in 8994 ACP with the security AD review. So I think we can shortcut this now by doing an early review with the security directorate at a point in time when we feel we should do it, and that the rest is fine.
Yeah. So would you like to first do the review or first add some details?
No, I think I'd first like to do Shepherd review and then go from there.
Okay. Yes. That seems good. Yeah. Then next draft is the constraint join proxy, which is very much related, of course. So this shows basically the same picture, but now highlights the role of the join proxy. It's basically a device that has already joined the network and then can help another device in the mesh to join, in this case, the pledge. So this is to highlight the updates, which are none since IETF 124. And the reason is that we do have some final open issues there. But so far, they did not yet lead to a decision to change anything. Two issues are related to core link format, and this is something I wanted to basically take to the next core working group interim, just do a quick check if those ideas there are feasible, and then if needed, adapt the draft then. So what are these open issues that are also to be taken to the core working group? Well, the first one I have already put my verdict on in GitHub. So the question is basically in the join proxy, do we need to support this new option, URI path abbreviation that I discussed previously? While it's very useful to support it in the register, my conclusion here is that it's not worth mandating this option on constrained IoT devices, so for the join proxies. And there's some detailed reasons also stated in the GitHub issue there. So overall, it's just that basically the size reduction for this operation is very, for introducing this option, the size reduction is very small for the discovery messages. So it doesn't really help much here. And the messages are not that big anyway. So these are unsecured co-op discovery messages and responses to that. Yeah, the other open issues are related to simplifying the core link format that's used for discovery of the join proxy. And in the current solution, there's basically a link format document being sent by the join proxy that includes basically a long IPv6 address in ASCII that is also unused in the link format payload. So that's why I wanted to find an alternative that is a bit easier and simpler and has some benefits. So reduces the payload size, and there's no need for the join proxy to generate the IPv6 address string just to be compliant to the specification, while this string is not really used by the client who receives it. So this is something I wanted to further discuss. So these are also the next steps, of course. Take this basically, core LF ideas to the core working group interims, which will start again, I think in April somewhere. And then also wait for the dependency to complete. So this is the end of the presentation. So it covers these both drafts. If there are any questions, let me know. Otherwise, we can move on.
Yeah, thank you very much. And would like to invite everybody here to consider reviewing the documents, commenting on them. These are still not fully through, so very good opportunity to do that type of review. And otherwise, I'll be doing the Shepherd reviews, and then we'll look for the early directorate reviews before moving on to the AD review. Okay,
Okay, thank you.
next. RFC 8366 bis. So, we're going to share slides. What? Who has this share now? I just clicked on, oh, okay, so let's take, yes.
Am I speaking?
Control, I have it. 8366 bis conference selection. And then plus, yes. So,
And thank you very much. Hi, I'm Michael Richardson. I'll updating on the status of 8366 bis. So we adopted this document some time ago, and I think we're almost completely done here. So the working group last call ended at the end of January. On that process, we added ESCO as a co-author, and we removed Max Pritikin with his blessing. He has not been able to be involved in the IETF for some years now. Our AD Mahesh did his review in February, and most of those comments were processed last week with version 8 posted on the Sunday. There's a 29 that was just posted. There was one change to the Yang that did not get through for tooling issues. So you'll see that, and that relates actually to what ESCO was talking about with the DTLS things, where there was some comments in the Yang about BCP 14 in the Yang, which just was not a good place to put it. It now correctly updates RFC 8995 and obsoletes 8633. That's clearer. All the references that were aliased from 8995 to Brewski were changed back to 8995. And that's because there are some comments and some things that refer to 8995 in the text where it's not, again, another reference because it's been said several times in that sentence. So this just removes confusion, especially among readers and reviewers that don't know those are the same thing. The list of Yang authors is now the same as the list for the document. The Yang was being 8792 wrapped, which was not necessary. The Yang is wrapped already, but it did confuse the data tracker. So that's been removed. And then I mentioned that this BCP's 14 statements in the Yang were removed, and ESCO, I think, has successfully put them into the Brewski document. And we're advised to remove the word grouping from the names of the Yang groupings because that was redundant. I was worried that that was going to break something, but it did not. And I do not think we have any external references to our Yang anymore. So that's not a, it would be a backward compatible problem if that was, but it's not. I don't think that's a problem anymore. So that's it. It's I think it's in Mahesh's hands again to go up to the ISG, and I guess that'll get a date sometime in April for the teleconference. The following is the list of 6 documents that are either in the RFC editor queue or are waiting to get through that depend on this document. So pretty important that we get it done finally. So that's good. And that's about it. Last slide is back up. Any questions?
Yeah, just a quick note that, well, I've got this one review comment here. Mm-hmm. Yeah.
Right. Not a question. Sorry.
Go ahead.
Not a question, just here to say thank you. Yes, it's a major document, just blocking too many other documents. They're all sitting on my queue, and I'm happy to review it after this IETF meeting. I'm off next week, but the week after, I do promise to take a look at it and send it off to ISG for review. Thank you.
You're not taking the document with you on vacation?
No.
No, okay, all right.
Brian.
Yeah, hi. I just wanted to say this is a no comment. I think it applies to ESCO as well. these are pretty specialized documents. So if people who consider themselves part of the general public, such as me, don't comment, it's not because we don't care, it's because we think only experts can really realistically comment on these documents. But, you know, I'm sort of very glad this work is being done, and I wish I understood it better, but I don't. And I think there's probably quite a lot of people in that situation. So thank you.
Maybe if it's useful, you know, I did some screencasts at one point. I don't know that they require, I don't know this document requires changing them, but if there's something way of making them more accessible, that's not, I'm totally into that. But I can only answer questions that people have. So
Yeah.
pose. All right, let's go on to the next one, which is the operational considerations. Let me see. Do I push this? I can stop the slides.
Okay.
Then you can push them. You have to approve the slides anyway. Oh, there you go. Yeah. Oh, I get chair. I can do that. Oh, okay. Confirm my selection, apparently. All right. I guess I did it. All right. So we had two documents. We've discussed this a couple times, but finally I put some slides together around this. This was the operational considerations for the registrar and the MASA. Thomas Werner has said he wants to be involved. I'm not sure if he's if he got up at the right time because he didn't travel, I know. So he's going to be co-authoring that, I believe, and we have to figure out what we're going to do. Thomas is the author of another, you know, triple of MASA registrar client code. So, and if there's any other implementers that want to contribute, of course, we would welcome that. So how did this start? So a lot of these things, I started this document in 2019, early 2019, as we're implementing and we're going through Brewski, and there was a bunch of things that I said, okay, well, this is not a interoperability concern, but maybe it needs to be written down somewhere. And I started just throwing them into two documents, and they grew and changed, and a bunch of text moved from some of these documents to a T2T RG document, which I hope will get published any hour now. Yeah. So then the question, as we adopted these in a couple of years ago, was, do we need two documents or one document, and what are commonalities between them, and what things could be said that are different. So this is what the table of contents for the registrar operational considerations is. Some of these things are, you know, in some ways almost extended security considerations, but they're more like, you know, which private keys you might need to keep safe, and what happens if you don't keep them safe, or you need to recover from that. But also things like what happens when you attempt to scale the registrar, and the obvious way is that you scale it horizontally, as most web properties do, by adding web servers, often in front of behind a load balancer. Although because of the discovery mechanisms, you could actually omit that and just allow the pledge to pick a random host. But then we get into issues of the joint proxy and other things that we've discussed. But if you do horizontally scale it, then the question becomes, where are the private keys? Are they the same? Are they different? Where do the signatures occur? And which keys do you pin if you have more than one? And some of those considerations actually came up early enough in 2020, and there were text changes to 8995, you know, kind of at the last minute to make some of this, because some of these did have interoperability issues, and so we did change some of those things. And there's some additional considerations, I think, in Brewski as well about how to pin things, because there are new ways of pinning things that matter, and you got to get them right or it doesn't work. So there are some diagrams and other stuff. There's the table of contents for that. And that was a little bit, yeah, I already said a lot of these things. So there's a little bit of, okay, you could do something as long as the implementation supports it, and that becomes a quality of implementation issue, until there are things that you can't, that another party can't do because they are trying to cope with a low quality of implementation. And so this is there's a little bit of back and forth here as to what to do. And honestly, it might be that this document in the end, after we kind of collect more information, and I don't think we need to rush in any way for this document, we might decide that we've collected all the information we need and we don't need to publish it as an RFC. But for the moment, it's there. So for instance, as an example, this RFC 999440, which you can see is relatively recent, which is the client cert HTTP header field. And you are not going to be able to put your MASA or your registrar, into something like an EC2 with a hardware offload of TLS if you can't get the client cert, because we need the client cert in, at least the registrar does, and the MASA may also need it. So you need that, and there was not until 994 actually a standard way of doing that. It was specific to the load balancer that you're using, if it supported it at all. That's an operational deployment consideration that implementers need to be aware of, but that fundamentally does not change the protocol. It just potentially breaks the protocol if you have someone that didn't understand it. They needed to do that there. So what else we got? So the MASA operational, the table of operational considerations, table of contents. And the majority of this has to do with what the PKIs you are maintaining, and how are you assigning the IDEV IDs, and how are you signing the vouchers, and how do those keys relate, and how do they go up to a single trust anchor that the pledge knows about? Does it go up to multiple trust anchors? Do you share those trust anchors across multiple products if you have multiple products with one MASA? And there's all sorts of different ways of doing this, and they're all essentially manufacturer considerations that they need to make a decision as to what they're doing, and then they probably need to stick with it over time. And if they decide to change their mind, then they have to deal with the forward and backwards compatibility with their own products. And so that becomes their issue for that. And then there's some concern about like business continuity, right? I mean, what happens if your MASA private key is destroyed in a flood in your data center? What do you do then? Well, you have a problem. But you might have business continuity, and you may have split the keys intelligently, and this kind of stuff. And that's actually some of the trust anchor T2T RG trust anchor document contains some more discussion about that, and what amount of disclosure you're going to get, and that kind of stuff. So yeah, so I just talked about that. So there is a bunch of PKI advice in both the MASA and registrar document, and this kind of collects those two things. And those things could go together in a merged document. We could have a lot of back and forth conversation about how to, what are the options for doing this, and how they apply to different kinds of things, and what are appropriate kinds of levels of technology or complexity that the registrar may want to do. And the three examples that I gave was, a tier 1 ISP versus an enterprise network versus a home network. The level of complexity and the number of things they may have to fix if they make a mistake differs between them. So you have to think about what's going on for that. So those are the things that you could collect and might more reasonably be publishable as a BCP. But again, I think we need a lot of actual experience before that's specifically useful to publish.
Mind a comment?
Yes, please.
So with respect to merging or non-merging, right? So it seems as if the MASA considerations are very much manufacturer considerations. So they're addressing a different community than the registrar, which is kind of the owner. And maybe we just want to change the names, right? So one is kind of Brewski owner considerations, right? Which is mostly registrar, but other pieces as well, kind of, don't buy pledges from people who really don't do good brewski or something. And then the other manufacturer considerations. So that would maybe be a good reason to keep them separate.
I agree. And further, the MASA considerations are not so much product mandatory to implement or nice to have implemented considerations, but actually become operational. What are you doing? Whereas the registrar considerations are many ways, if you got a registrar and it doesn't do these features, then you probably aren't going to be, it's probably the wrong choice for you.
Right. And the other part, obviously, my pet peeve is the use of sub-CAs as a mean to, simplify manufacturing, right? Because you're typically contracting as a big manufacturer, some manufacturing plants, and they need to have their own sub-CA. So if something like that isn't in the text, then I'll be happy to try to figure out where to put it and see that we bring it in, because I think we've been going through the trouble of making sure Brewski, and now Constrained Brewski supports that. So I think that's a major help in supporting flexible deployment.
There is actually a fairly sophisticated operational market now, so busy they won't talk to people, of doing factory installed keys, and multiple companies with multiple products that help people do it. And yeah, they seemingly can support all the different options here. It's just getting them to actually, they're so busy working, they can't be bothered to market. Stefan.
Hi, good morning. Yeah, maybe just as some side note regarding the merging of the documents, because I think I proposed this, or we discussed it in the design team. The reason for merging it, basically, from my understanding, would be beneficial because the MASA operator and also the registrar operator, they would somehow interact. On one hand, for doing some kind of trust, or may do some kind of trust establishment before, but also on the other hand to during operation, and to have some more background on the operational side of either the registrar or the MASA may help to understand doing certain design decision or doing certain operational decision on either registrar or MASA side. So that was essentially the reason for proposing to merge both documents.
I agree with you. It would both give them it would give both operational personnel a common language by which to communicate, usually because something didn't go right. And they say, oh, well, I am a per product intertwined dev ID PKI. And the registrar person says, oh, we don't know how to do that. Okay, we'll file a bug report with our supplier, right? Or something. And they would know what it is that's there. And I don't think it has an operational impact, but bugs are bugs, right?
Okay, thanks.
So there's scaling advice and about this, and there are considerations around what keys do you create, and as Torles just mentioned about having subordinate CA keys, and that's one of the ways of doing horizontal scaling between, like, you could have a manufacturing plant that or you could have manufacturing in multiple locations, and so that's one of the ways is don't share that private key because you do two subordinates, or you have the CA online and it's operational when the plant is operational and it's not otherwise, and there's things like that. There's a diagram in the registrar document that I think is on the next slide that deals with some of the architectural things in the registrar doing horizontal scaling. And I think, let me see if that's the right one. Yes, there we go. So, this is the thing. So one of the ways my implementation is monolithic. All of these objects, except the database, really are all in the same process. And so when you do when the pledge does an enrollment, which is the bottom side of things, it waits while the system talks the massa. There could be a timeout. There's some mechanisms in 8995 to deal with that timeout, to retry and things like that. But one of the other ways of doing this is that the pledge interface could receive that voucher request, could stick it in the database, and then wait for some other process to pick it up and do the mass interaction and return a voucher to it. And it could always tell the waiting pledge that it's going to have to wait and come back. And I don't think my code actually supports that. My pledge code supports that. That's a bug. But there's different ways of doing that. And when you do those different things, you've got to decide, well, when the registrar signs its registrar's voucher request, is that private key on the bottom? And so you put a signed thing into the database, or is it on the top box, in which case you maybe have one of them across the different things. And there's different ways of doing this. And that's one of the things that comes into, what are you pinning exactly? And are you going to, if you horizontally scale the pledge interface and you do the signing down there, are you going to create slightly ephemeral registrar keys here for signing it, but you're going to make sure to pin something above it? So you have to figure that part out clearly. And this does have an interoperability implication. And I think we got it right already, but that's part of the process here. In the registrar document, we have this diagram that I created at the very beginning. And the intention of it was to talk about network and ACP partitioning and what happens to a network when you're trying to, say, bring on a new device, but the network is broken, it's partitioned, and you might not be able to get to the registrar you thought you're going to get to do it, bring things back online. And maybe that was too ambitious for this document or too early. And so I would at this point rip this diagram and much of the related text out. But, you can imagine that, you had, I don't know, this Tokyo router, it's crashed, it's died, you have to replace it. And, but because it's down, your network is potentially partitioned and you can't get to all the other places you wanted to get to directly. So, how do you get that router online so that the network is no longer partitioned so that you maybe can get that router online? Well, you got to plan for that ahead of time. And that's why in this diagram, there were 2 NOCs with JRCs and 1 without, just an EST. And so, I don't know, this is some of the thoughts I was having some years ago. I think it's too ambitious at this point. I don't think I would like to rip it out unless someone else thinks it should remain.
You can assign something to me. I can think about anything ACP related.
Okay, please think about this, and let's think about realistic, real scenarios that we might know of. Ideally, with real ISPs, kind of thinking about this. How would this work? Where would we do it? Or maybe back of the tabletop, gamification. What's the right word? When militaries do game top strategies. I mean, so basically, where should the JRCs go? How many? Are they redundant? How does the database replication work, if there is database replication? And what does that mean for bringing the network back online after something happened, right? Whether it's a flood, a power outage, or just a tsunami, or just blue smoke escaped, right?
So there actually is a bunch of these considerations already in 8994. We can point to them. Can we speed up it just a little bit?
Yeah. I'm pretty much done. So, I suggested this table of contents, ignore the numbers. We will renumber them, obviously. That might be the operational only document. So that's just about operating things. So one document might just be, these are operational considerations. This is not about things that you have to worry about while you're building the thing. And maybe that's the thing, that's the right answer to merging it, but not everything merges into it. And then you wind up with implementation guidance, which is potentially not a publishable document because we don't really need to publish it that way, but we need to talk about some things. And there we're done. Yeah, that's it.
Any questions? Okay. So I'll quickly take this sitting down here. Update on Brusky Discovery. So I managed to get a review from Stuart Cheshire, which is the author of DNS-SD and MDNS. And in response to that, I went from 09 to 11. Did an English run-up, actually for the first time with just actually doing an AI tool. So if folks are interested, just number 10 is just after the Claude AI English checking. So actually a lot better than the previous tools I was using. I added text to introduce and expand on the Brusky term so that folks who only understand discovery but not Brusky hopefully should be a lot more happy with this. And then did rework section 3511, which was just trying to explain that when you're deploying DNS-SD in pledges, pretty much, that there is a wide variety of ways on how DNS can be set up, how you discover the DNS server so that you can even find where to do the lookups into, added references to that browsing part of DNS-SD. So hopefully this is all a lot more instructive, because I think one of the generic problems that we have is that most of the successful use of DNS-SD is using some not necessarily public domain libraries in desktop operating systems, whereas in the pledges we can expect a lot of one-off implementations, and I'm a little bit worried that they will then be too constrained to actually be easily deployed in any type of, let's say, environment where they should actually work, but some parameters are different. So that was that section. And then, yeah, so in the way I defined how the variations are to be encoded in DNS-SD, that was well-meaning, but it wasn't well done. So the real problem is that the encoding was meant to be as easy parsable. So Michael has always been pounding on making everything for pledges easily parsable. So we just have a list of strings, each of which is a variation. And unfortunately, I was ignoring the should be no more than 9 characters long of DNS-SD RFC. And that means would be breaking a should requirement. And it can easily be that libraries don't even allow more than 9 characters. So now I've changed the encoding to be one variation key, which is var for variation, and then the variations are just the values separated by commas, which is a fairly standard procedure. A little bit more to parse, but unfortunately unavoidable if we want to stick within the should recommendations of DNS-SD RFC. So I think I'll go do one more round before passing it on. And the open issue is still that there are 3 big IANA tables that IANA did approve. They're a little bit more review I need to do on them. I think I got another early review from IANA, but they will continue to exceed 72 characters, but they really look lovely. I would love them to be in the same format as they'll be on the IANA, and I don't know how to do that without pulling more tricks, like converting them into SVG and including them as an image. So I'm going to have some more discussion with the RFC editor folks to see what I can do, because what Michael was recommending some time ago, which was marshalling everything into stupid, list text, will not read nicely in the RFC afterwards. So any other ideas, obviously welcome. And that's it on this one. Any comments, suggestions? Yeah, Karsten is a definition list, but it doesn't look nice in the RFC, right? Why the heck do we have so stringent rules? And I know you had to do it, but yeah, I'm trying to fight the system on that to get a nice RFC. But if I have to cave in, sure. All right. No more questions? Good. Then we'll recapturing some time. And we go over to the next presentation. And that would be, oh. Yeah. Constraint graphs. And then slide clicker. No. I think the mic is not on yet.
Hi, this is Longwei Zhu from Beijing University of Post and Telecommunication. I will present our latest updates of CGRASP. The CGRASP is a lightweight version of GRASP, which by replacing the TCP with the CoAP, the lightweight protocol designed for constrained devices in IoT. The CGRASP leverages the reliability mechanism of CoAP to provide reliable signaling services without the heavy overhead of TCP. CGRASP is defined as an application layer service built on top of CoAP. It reuses transport and reliability mechanism of CoAP, while the CGRASP messages are encoded as the payload of CoAP. The CGRASP mechanism are directly mapped onto the CoAP request response exchanges. For example, the discovering and flooding process of GRASP are mapped to the non-conformable CoAP multicast request using the no response option. And the negotiation and the synchronization are mapped onto a series of conformable CoAP post exchanges. And using the consistency token to ensure the session continuity. There are several updates in the IETF 124 on the mechanism side. We have fully designed and optimized the multicast relay mechanism for CGRASP. On the just writing side, we have formally clarified the typical application scenarios of CGRASP. For example, the age coordination in industrial IoT. On the prototype development side, we are migrating the TCP-based GRASP developed by Brian to a CoAP-based prototype, and the unicast CGRASP interaction process is almost done, and the newly defined multicast relay mechanism is to do. The key update of CGRASP is the relay over CoAP. Since since CoAP does not provide hop-by-hop multicast forwarding across multiple links, the seagrass must maintain a relaying mechanism and function to expand the scope of discovering and flooding. To achieve this, the relaying node must maintain a relay cache to prevent loops and reflooding. And the processing and the forwarding steps of relay mechanism is carefully designed. Every relayed message must be check its loop count, and after loop count check, the message must should be encapsulated into a new CoAP request with fresh CoAP metadata like the CoAP message ID and token, and then it will be sent as a non-conformable multicast CoAP message with the no response option. Upon receiving a discovery response, the relay node should look up the relay cache and forward the result to the upstream initiator via a new unicast CoAP post request, and utilizing the cached upstream token. We also advise to enforce a rate limiting mechanism to mitigate excessive multicast traffic. The prototype implementation of CGRASP is ongoing. During the development, I found a challenge. As we know, the CGRASP is P2P, while the CoAP is client and server. There is a saturation, prolonged negotiation involving wait message will break the simple CoAP request and response lifecycle. If the wait message sender acts solely as a CoAP server, it cannot easily push the subsequent messages when resources become available. For this reason, every CGRASP-enabled node must act as a both CoAP client and server at the same time. We handle the wait message via a role reversal logic. When node needs to handle a suspending negotiation, it can actively switch to the CoAP client role. It will transmit the subsequent messages via a new CoAP request and a CoAP context to the peer's listening port. And the combination of persistence CoAP token and the CGRASP session ID will bridge the gap between the disconnected CoAP contexts. Towards the next version, we intend to add some explicit implementation guidelines for mapping P2P CGRASP to CNS CoAP. And we also intend to provide some concrete interaction example for the bidirectional context handling. And on the prototype implementation, we will continue to implement the role reversal logic and implement the newly defined multicast relay mechanism. That's all my presentation. Hope for your comments and questions.
Brian? Brian, do I have some question?
Yeah, sorry, your voice is very, very quiet. This is Brian. Thank you very much for playing with my code. If you have any problems with the basic code, please just ask me, because I can still remember roughly why I did it. I had a question really. Is M-weight useful? It was included in the original specification because we thought it might be useful when the responding party wants to delay a negotiation beyond the normal timeout. But one way to look at this problem is just use a larger timeout and don't implement M-weight. I think that's a question you could consider.
Thank you for your question. I will carefully consider your question after meeting during the prototype implementation.
Fine, very good.
Okay. I have a quick comment. I mean, your implementation plan is only talking about how to implement the design protocols, but it would be very helpful you actually set up some demonstration with some typical use cases to demonstrate how the new protocol can be benefit for certain scenarios.
Yeah, the use case will be considered and implemented for the target C grasp using scenarios after all the basic implementation is done.
I mean, you don't have to wait for the full version of the implementation. Whatever the function you have done, if you can, make that used, you can have that use case first.
Oh, I got. And maybe I will plan to update the application use case in the next draft.
Yeah.
Yeah.
Thank you.
Thank you.
Any more questions? Okay. Next. Should mine? Okay. Okay. Here we go. This was a document already packed for almost 1.5 years. The major reason we packed this document, it was already adopted for a couple of years earlier. The reason we packed it is by that time we only have one example use case with many focus on the quality transmission scenarios, which actually was, good resolved earlier in routing error. It's not some new use case. Although we claimed our framework is for all kinds of network resources. So we packed our working group document. This time we come back, we extend the framework to be intent-based. If you were, stay with ANIMA long enough, you may remember that we actually have intent concepts very earlier back to 2013 or 14. We have very clearly defined network intent in the reference module of Autonomic network RFC. That's 18.9.19.3. Anyway, now we come back with the full intent-based framework and with more example use cases we are working on. So the major change from the version we have almost 1.5 years ago, we dedicate the 07 version to intent-based mechanism. 06 version was more generic based on the resource ASA discovery, which means, there's no intent. We assume that the network already have some source, some input for, the service request, whatever. Now we actually have the intent to give us the abstract request of the from both user or network management. So we actually extend the concept of network service a little bit from only the network management to also cover the requests from the trustworthy users. Here, I would like to emphasize the trustworthy users because by default, the network is not trust the users, but that's why earlier we don't have a generic version to cover the requests directly from users. But in ANIMA, we have different assumptions. In ANIMA, we have all the users through the ACP, and we have Brisky, which guarantees the security base from users. So now we have the trustworthy user as our input terms. So we can work on it. Now this framework is generic and applicable to most types of network resources. And that also covered in below 2 new drafts, which we hope this time with those 3 or even more drafts, we cover what we want to for most of those kind of network resources. That's 2 new draft is the definition of the service intent in autonomic networks. We are not going to define the intent for all general use cases, but within the definition of autonomic networks, as I explained earlier. And we also have more detailed mechanism how the intent-based service intent can be autonomic deployed within our autonomic networks. So with that, the title of our draft is changed a little bit from the generic autonomic mechanism for resource-based network service to be intent-based framework of service, network service, autonomic deployment and management. In the introduction section, we reworded the problem statement to highlight the dynamic and diverse requirements from the trustworthy users. We revised the description of the proposed solution to emphasize the intent-based framework. We also update the list of the use cases to better describe that, including the quality transmission and the difference transmission, in-network cache and storage, also the computing offload. And we added a new scenario, very specific for the multiple resource management in data center, which is also the limit domain, which is very good use case for our autonomic network. We update the terminology section a little bit. We only added the network service within the context of the ANIMA. We reversed the definition to be specific service is a customized complexity of network resources. We newly added concepts for the service intent to be the declarative expression of requirements that specific network services serving as the input for the resource dispatching. We update the service initiator, modified the definition to state it receives and processing a service intent by facing the intent into discrete resource requests. In the service deployment section, we describe the generic procedures of the autonomic deployment and management of the resource-based network services in abstract way, and define the autonomic resource management objects, which was we already done earlier in earlier versions. We only added the newly added the section 4.1 that covers the procedure, how the service intent initiates the resource management ASA for network for service deployment. The rest is the minor editor change for the rest parts. We also removed section 5, which was major use case as an example earlier, which is the processors of the quality network transmission service autonomic deployment. As I explained, the reason is we have more network resources, more types of network resources covered, but we move that into another independent draft. So the next step, that's a little bit mess there for the slides. We will complete the whole framework together with the two drafts we mentioned. Although the framework draft is not dependent on the that two new draft, definition of service intent and the autonomic deployment mechanism. That's what we are going to do. We already received two good comments from Brian Carpenter and William Atwood, and William told me, they already he already have some kind of implementation test bed, which would be very a good platform for us to do some implementation on it and make the evaluation tests. Yeah, that's it. I guess for the agenda, the R2 new draft will be
that would be next. Yep.
Next. So,
any questions? Yeah. Okay. Yeah, one line of thought to get more feedback would also go back, give some overview, and try to address NMRG, right? Given how they've been doing a lot of work on intent, they might be interested to look into things that are trying to take intent to the next stage.
Oh, you mentioned ANIMA,
yes.
Network Management.
Because they have done a bunch of definitions.
Yeah. Why not? I mean, actually, if you guys remember, around 2015 and 16, just after we set up the ANIMA working group, I actually run a network machine learning research group in IRSG. By that time, we were too optimistic to think, we have enough intelligence to be able to break down the abstract intent to be the network configurations. But that's we don't have that kind of smart algorithm by that time. So that's why the network, machine learning research group stopped there. But now with more, intelligent algorithm and also the AI algorithms, I think that's time we can do more on the intent-based, and we will continue to do that for the network management purpose.
There is also a workshop on Saturday between NMRG and ETSI here. So if you're not staying, but you have slides or so, if they still have time, we can. Okay, sorry, taking notes and sharing slides. We'll get there. Oh, come on, please. Yes. Okay. Stop slides, start slides. So now we got 2 separate presentations. Let's hope we get the right one. Do you like this one?
No.
No? Okay, then we'll take the other one. Okay. This one?
Yeah, this
Okay.
one. Hi, this is Longwei Zhu. I will introduce the new draft called the definition of service intent in autonomic network, and Jia Lu will introduce another new draft about the autonomic service deployment based on service intent. The traditional service description are inherently connection-centric and focus merely on endpoints and the basic transport metric, which is unable to represent the quality objective for complex multi-dimensional tasks. Such as the new emerging services like the interactive media and AI inference, which require more than just a network path, and always strictly constrained by the coordinated use of heterogeneous resources. So we think we lack the semantic to express cross resources coordination constraints. For this reason, we introduced this document and focus on the semantic model and format of the service intent. The service intent is defined as a structured machine and machine interpretable declaration of design service objectives and resource constraints across the heterogeneous infrastructure. In summary, the service intent is outcome-oriented rather than configuration-oriented, which enables the autonomic service deployment. The service intent is defined with a concise format, including 2 parts. The first part is the metadata for identification and lifecycle management. And the core part is the intent content, which is defined as a structured object that specify constraints across the multi-dimensional resources. There are 3 types of intent content object, the network resource requirement intent, the storage resource requirement intent, and the compute requirement intent. Recently, we have received some active and valuable discussion about this document. We have got two key feedback from Brian. The first one is the need to formalize the intent data format with JSON or CDDL. The second is about how to handle the hard problems of the intent scope. For this issue, we think the existing ANIMA architecture and the protocols like Brewski and ACP will be helpful. Towards the next version of draft, we intend to add some clarification to reference existing ANIMA specification for the intent scope issues. And we also intend to standardize the semantic definition into strict CDDL or JSON schema. That's all my presentation. Let's move to the autonomic service deployment based on the service intent. Tell us maybe the next slide.
Working.
Okay, good morning, ladies and gentlemen. My name is Jialu Du, a student from Beijing University's of Post and Telecommunication. Today, I'm very honored to share our draft work, the autonomic deployment mechanism of the service intent in the autonomic deployment. Just listening the two draft just now, I think you are very familiar with some conceptions such as service intent, service illustrations, and responders. So our objective of the draft is to translate the high-level service intent into some resources requirement and reserve them across the network by some negotiation and mechanisms. So in short, we have three key points. The first one is intent phrase. In this step, we will have we will translate the service intent into a structure requirement, and then we will have we will compute the routines and select the responder for the negotiations node. In this way, it can, according to the current resources and as well as the intent limitations, to find the node with negotiation each other. The last step, we will have the negotiations. The initiation will create a grasp message which will carry the requirement and may send to the responders. After the negotiations, the user's responders will deploy the resources. Our work is based on the user's intent. We think it is very necessary because you can just imagine a service will have a flexible QoS need. And users and operators cannot and very hard to express the exactly value for the intent, but they will very prefer to have prefer to use the natural language to show it. So by the way, we just want to design a standard method to translate the natural language into the structures users resources requirement. Now, I'm very glad to show you the intent-based service deployment. We can see these figures. Users may use the descriptions of the natural language, and it will submit to the administrators. When the submissions, the administrator will have the model can intent the pricing the high-level user's intent into three different types of resources. Just the network compute and sortage. After that, the initiators will select the responders and have a negotiations process. When we have the negotiations, we just use the different label to show different type of the resources. You can see the left one is network resources, and the right is compute and sortage. When finish the resources, we finish the negotiations, the responders will deploy the resources. Just now, we considered two scenarios about how to choose the responder. The first is we just use the routers as the compute device. In this case, the initiators will consider the joint both the select path and the use and the node selections. Another one is simple because it just need to access the compute and the sortage service. So in this case, we can just choose the node first and then to have a computer route to communicate with the forward node each other. Now I want to show the negotiation process and about the initiation and the responder. First, the initiator will create a grasp message. It will carry some intents and proposal list. The right way can just show our extent of the message object. We can see we just add two structures, the intent and the proposal list. The proposal list means how many resources can the responder provide for this service. Next, the two node will have the negotiation process. It is will several times until the administration accept the negotiation. After the negotiations, node will notice all of the responders to deploy the resources. In this process, first the administration will first collect all of the proposal list and have a check. After the checking, it will flow the message for all of the responders. After that, the responder will have the deployment of the resources. I want to show you that it's a dynamic life cycle process because when the work is continuous, if the resource state have changed, the responders will also send message for the node and have a negotiation again until it is satisfied for the resources requirement. After the task was finished, it will all of the responders will release their resources. Now is our feedback for this work and our next step work. In the future, we can consider to use the dry run as for the RFC grasp to for our release for the resources, and we will have a check for the format of the message. This is our presentation. Thank you for your listening.
Any questions?
Hi, Michael Mackey, Huawei. I was just wondering, was there any, I've seen a lot of stuff about intent. Sorry, I just walked in. I haven't read any of the drafts, but I was wondering if there any alignment done with the TMF. Is it 921 TMF intent API? It looks very similar.
Remind me of the SDO that's from.
TMF.
Okay. Mm-hmm. Well, I think we can take that offline.
Yeah.
Okay.
So I would like to remind you to invoke more discussing management. Oh, that's fine. Not only for this new draft, also for other new drafts, I would like to remind the authors to try to invoke more discussing in the mailing list. We will see the feedback from working group to see how it's, we may propose it, process it later. Yeah. Okay, next. Yeah, 洪耀。
Okay, I'm Meng Yao from China Unicom. And on behalf of our co-authors, I'm going to do this presentation. The title is Consideration the AI-powered ASA Communication and the Scenarios. Firstly, I will give you a brief introduction of this work. So basically, I think that some AI is very important now, and there are some large skills network models can gain the great attention in the AI networking. And we think it integrates the networking technologies and the LLM with broader potential. So it can provide for the networking to especially for the capacity networking OM for our operators. And so we think based on the ANIMA group's work, they have the automatic service agent. So for here, we could consider to combine the AI technology and the ASA. So we call it the AI-powered ASA. So maybe it can achieve more intelligent management functions. So in this case, it can to boost the OEM efficiency with the OEM and some agent or such as OpenClaw or something. And next is I want to show is a simple vision of the AI-powered ASA. So this is a topology. We think is from this picture, there are the users and the enterprise to get our private LANs or the dedicated LAN to the DC to get maybe the traditional cloud survey or now the intelligent, such as the training and the inference service. So based on this typical and scenarios, we can deploy the ASA from the gateway of the user and also the DC input, and also in our routers. So the AI-based ASA can also use the graphs to negotiate and to transmit some devices information and some result and the service information. So from here we can achieve the intelligent networking from the automatic networking. Okay, next I will to show some scenarios. This work we also to show in the WG, and we have a draft is a congestion relief. For here we have separated two scenarios. The first one is this is ASA communication between the network devices. So for here we can use the traffic analysis and to for here maybe we can use the AI empowered some method and algorithm to get the more accurate the traffic result and to get the distribution of the traffic, and then we can direct it to traffic the devices, and this is when the the network failure or the fiber failure, they get the congestion. So for here we can see this picture. There are two paths from the C1 to CR1, and for here if one link is down or have some failure, it can automatic to change the path to another. And in here, they can get to use this working flows at step 1 to step 5. And for here, we have do some work in here, and according to the WG comment and the Brian's code, we do use the use the grasp to define the new objective to do this. This work well to update this draft in the following. But for here, we can to say if we also use the AI method, such as the previous presentation since the intent service. So it maybe can to use for here. I think the service for here maybe is our operators, the network management for here is a congestion relief. And next I will show the next work is we have to show in the V6 ops working. And here is a IPv6 monitoring and the analysis. So for here, I think we can use the AI-powered ASA to collect the data from the routers, and they also can use the grasp or the protocol to transmission the information to the controller side of the management system. I think though we can get a more accurate result by use the AI model or the algorithm, and then they can give us more guide to deploying the network and also to the CDN deployment. I think this also is scenarios to achieve such as the intent based service. Okay, and this is the next step. I will to take an active part in the ANIMA working group, and then I think we can do a lot of the AI related work with the ANIMA's automatic the networking, I think. So, and also I will to update the draft such as to define the new graph objectives to achieve the congestion relief and to keep the scene relief. And today I should just say some AI related topic in working group, and I hope I can find more feedback and comments. Okay, I will stop here. Thank you.
Do you have any online question? I went through your draft. Actually, the terminology you use is getting confused because in sometimes you use the agent reference to the autonomic network agent, which is our ASA in ANIMA working group. But in more places, you actually reference the agent to be AI agent, which is the directly used by the end user. So and you give many example of the AI agent, which is for us more in the application layer rather than working on the network. So that gets me very confused. We encourage you working on some very specific ASA, which we call it agent, but that's the autonomic network agent, autonomic service agent in our ANIMA. But that seems not cover the AI agent you mentioned. And there are gaps between those two concepts.
I can to consider to clarify this thing because the ANIMA maybe the 10 years old the ASA can define, but now we don't talk the AI agent. But for now there are a lot of hackathon set a meeting to talk to the agent. I think this is a new work and can to empower the networking. So we try to define some things and found the combine the point to the ANIMA group. So we talk the AI agent, but the agent is too same, but maybe we need to clarify some things in our draft. Yeah, and I think we can do something and to further in the ANIMA group. Yeah.
Yep, I was in the queue.
I mean, as the working group chair, one of our main job is to, clearly draw the line. What is the scope of our working group? What is suitable for IETF to do, rather than, expand our unlimited. So we would like to make it very clear, our ASA we're talking about here is for ANIMA working group, and we are doing the network management stuff rather than way how to serve the application layer users. Okay.
Yeah, I see. Yeah, I see ANIMA has a clear scope for here. The ASA is for the the setting scenarios in the ANIMAs. So I think we can to refine or yeah, but just today I will to show that it's a simple image or the idea. But I think I can get the practice from the previous. We can do some intent-driven service. Maybe we can combine with our scenarios and can to empower our operators networking. I think that will be the next step.
So the ASA, before people were thinking about AI agents, right?
Yeah.
Were simple, algorithms to perform some automation on whatever function it is. And the configuration of those ASA we call intent, right? Which is an abstracted way, as simple as possible, to say what the heck should be doing, right? So distribute keys for a routing protocol, for example, right? Yes. So this type of use cases for an ASA is nice as an example. Yeah. But when we're talking about AI agents or AI in general, the question is not what you want to do, but how is it different to do this with AI agent than in before, right? So, and there are multiple ways, right? The first thing is you can simply use the bloody AI to program an ASA, right? So building the algorithm, doing it, you let an AI agent program it, you let an AI agent program a validation network so that you're testing the whole thing. And on the router, you have no change whatsoever, only you used AI for the development. So that, I think, is a perfect valid option to describe informationally for these ASAs, right? Because I think that's a great way to leverage it. And the other one is you may have LLMs in the routers, right? So next generation router hardware will have the capability to use LLMs. What the heck can you do with them, right? And so, right? Think about it from the perspective of how does AI potentially change the way to do the automation, and describe that in the document. And these kind of IPv6, whatever the feature is just an example that you can roll with.
Just slightly the different from Terrace. Well, when Terrace mentioned, how we use AI to, enhance the way we use ASA. Actually, I think he's already, crossed line a little bit, because he said we may use the AI to validate the network plan or validate the routing. That part is difficult for standardization. It's very useful for what kind of research or engineer work, but that's within the controller or within some network management tool, which is not the protocol work between the different autonomic nodes. So for that part, I'm not sure that's in the scope of the ANIMA. What we would like to do is to say the information exchange or coordination between the autonomic nodes. That's the protocol IETF working on, right? So,
Yeah. I see. So basically, we have these scenarios for maybe it's good for the ANIMA, but I think the AI is very flexible and it's more application and not for the network. We maybe don't need to a lot of standard to limit the deployment and to achievement. Okay. So I think we can to deep this research and to do the signaling and protocols and to approve for our scenarios. Yeah.
Okay.
Bing Liu from Huawei. First, thanks for the presentation. And if I can jump into the discussion, I think there are two aspects. One aspect is that we just consider the AI or agent stuff as kind of a powerful tool that might bring us more use cases or even to make the original ANIMA's vision more feasible today with a powerful tool. And I'm glad to see at this presentation showed there are some new use cases like the intelligent monitoring use case. If there's no AI or agent capability, that kind of use case may not be feasible. That's the first aspect. The second aspect, I think, is just at the second bullet argued. There might be potential impact to the current ANIMA's technology. Maybe if the ASAs that powered by the AI, maybe they can do more flexible negotiation so that we might, from the protocol perspective, we can allow the ASAs to choose their own objectives. That's my understanding of the second bullet, but it's still a theoretical consideration. So I will be very glad to see some real use case. Yeah. Thank you.
Yeah, I partly agree. With this AI enabled, our ASA could be more intelligence, but as normally, we never standardize what we do within a single ASA. What we could standardize is, the format, those ASAs talk to each other, and the way they, active, and we standardize their behavior, when they talk to each other. So I'm totally fine for, AI-enabled ASA that make what we think is not capable in 10 years ago, more feasible. That's fine. But again, what we could do for standardization is very clearly between the nodes. We should have the standard behaviors.
Yeah. Fully agree. Yeah. And for the second bullet, I think we need more gap analysis. Yeah. Thank you.
Yeah. Okay. Yes, I agree with you. Yes, for the grasp, I think for the different scenarios, maybe we need to define the new objective. Maybe we can give some gap analysis for that to maybe can for the AI empowered. Yeah, that's my.
Okay. Thank you. Next, Chen Yao.
Hello.
Oh.
I'm in the queue.
Oh, sorry. Brad? Oh, sorry. Your turn. Go ahead.
Hi. Yeah, just following up on what Bing said. Hi, Bing, by the way. I think there is one gap analysis that would be useful to ANIMA if people who understand very well what an LLM-based autonomic service agent might do could tell us if there are any gaps or problems in the primitives that GRASP offers. You know, is there any kind of interaction between two ASAs, assuming they're AI-based ASAs, that GRASP does not support? That would be a bit of useful feedback.
Sure. Yes.
Yes.
Thank you.
Hello everyone, Kahan from China Mobile. So today's topic is about like GRASP objective for CAS metric distribution. It's zero version of the this draft. So I'm wondering if ANIMA is interested in the draft. So I'm sorry, the slide seems not working. Sorry.
Oh, that's clicker.
Okay, thank you, Thomas. Yeah, so a quick background for what is CAS, because I'm not sure if anybody understood what's CAS. So CAS is about it's a TE approach, traffic engineering approach, aiming to optimize traffic steering to service instances by jointly considering dynamic compute resources and network states. So you can consider that traditionally when you want to do TE, you are selecting a path. And now considering that service providers can provide both computing and network service, you can select both network path and the service instance. And then, so what's the relationship with ANIMA? So CATS right now is a working group in routing area. We have to like use case and requirements. We have the framework will be publication soon. And also the CAS matrix definition has been, will ask for working group last call. So next we will start CAS solution. So CAS require, distribution of the computing matrix across the network to enable the next stage is a path selection decision making. So we need the proper signaling protocol for matrix distribution. So we see that GRASP is a potential candidate which fits for like a distributed deployment model. And okay, so this document's goal is like we want to define a unique GRASP objective for CAS matrix distribution and specify data encoding format for encapsulating CAS level 0, 1, 2 matrix according to CAS matrix definition. And then we will standardize two GRASP-based matrix distribution schemes like active flooding for proactively for disseminate the matrix, and then on-demand synchronization that the one of the network decision maker will to ask for the AIC on the computing node for matrix. And then we will define like message format, processing behaviors, and cache management rules for AICs. And yeah, here was some basic introduction about the GRASP objective for CAS matrix distribution. We will define a unique GRASP name called local zone CAS matrix. So it's an intuitive, it's a tentative name. So we welcome comments from ANIMA on whether the name is correct or some valuable suggestions on this. So basically 2 parts. On the first, local zone represents that the single domain you deploy CAS service, and the CAS matrix on the after the column is represent the you want to distribute CAS matrix is an objective. And then about the whole data structure, here we use CPUR format. I know that I already received some comments from the list then why you don't use CDDL. So I'm sorry, I'm not an expert here. I'm trying to learn CDDL, and I just give an intuitive, expression on CPUR, and I will seek for feedback from the list and improve the document. And then some about the distribution schemes. About active flooding is basically based on grasp mFlood method, and then on-demand synchronization is basically depend on like two messages, like a request synchronization and message sync. So we have embed some CAS matrix into the message and then to implement for implementation. So for the next steps, like just as I mentioned, CAS are starting to solutions. So basically, the stages for CAS, like you need to first discover services, and then you collect matrix, and then distribute matrix, and for path selection. So for matrix distribution, we need cycling protocols, for example, PGP, GRASP, etc. So as CAS working group suggests, detailed protocol extensions are left to working groups that incubate this kind of basic signaling protocols. So we authors come to ANIMA for soliciting GRASP experts' technical advice, and we authors will coordinate CAS with ANIMA on this draft. Thank you.
Yeah, thank you for the draft. So I just would like to know what's the attitude of the CATS, because CATS is another working group, right?
Exactly.
So they already defined the CATS metrics, right?
Exactly. Yeah.
So do they think that's ANIMA or GRASP is tool protocols for them to distribute the metrics?
I think right now we haven't decided what protocol to distribute the CAS matrix. We have several potential candidates,
Yep.
but we need more analysis on existing protocols applicability for distribute at CAS matrix.
Sure.
So we are just at this stage anymore. So we encourage people who are interested in this area and join this discussion. Thank you.
Okay, because that could be the official way IETF work is one working group makes the use case and makes the requirements for another working group. That happened in Six-Man and DHC working group earlier many times.
Yeah.
So because that will avoid the duplication efforts for multiple solution to solve one single question. So we would encourage you, to get some kind of, conclusion or official attitude from CATS working group. Then we would like, very glad to request to. What? Oh, sorry, I face him. I mean, if CATS working groups reach the consensus, they would like to use GRASP as their protocol tools to distribute the metrics. So we would like to work on.
So I talked with the CATS chair. So the first thing to do is to have an applicability statement for CATS for a particular proposed solution. So we need a CATS document to propose a GRASP. Then obviously how to do it would be ANIMA. And then I think we'll also have the dependency, the draft that I'd been presenting ago, which is kind of how to most simply deploy GRASP with security without our whole ACP stuff, right?
Yeah.
So ultimately, it sounds like a good opportunity, but I think we would start out with the applicability statement in CATS, because if CATS likes it, then we can do the ANIMA work. We're kind of the, they have the use case.
Yeah.
We can provide
exactly.
the technology.
Yeah, I think CATS is just starting to work on the analysis, so I think it's good.
Yeah. So Adrian was saying, write the applicability statement, present it.
Yeah.
And we can go from there.
Thank you. Okay.
Bing Liu from Huawei. Thanks for the presentation. Personally, I think it's a very proper leverage of ANIMA's technologies to do this thing. And two comments. One is that for me as an ANIMA guy, I'm very glad to see this to bring into ANIMA working group. But I don't know whether people in CATS or maybe in the routing area, there will be some argument why use GRASP rather than IGP or BGP. Or personally, I think GRASP is efficient and maybe much more lightweight than using the routing protocol, but I don't know whether there will be consensus among the CATS people and routing area people. The second is that just as Torres pointed out, we need to decouple the ACP with GRASP. And I think it's a common issue, not only regarding to this specific draft. And I think it's really important. And if we can do it in the working group level, that it is allowed, I think it will bring us much more useful use cases. Thank you.
Thank you.
I hadn't brought up the draft today because we'd be running out of time. I was just saying that for the cat story, we'll need it too. Obviously, I'd love to see it anyhow in ANIMA. Yeah.
Thank you. Okay.
Do I still have time? The last.
We just have 4 minutes, so I think we'd be cutting out of time.
Okay.
But it's in the meeting materials, and please bring it to the list first, and then we'll bring it up in Vienna, the latest. Do you want to take? Huh? Okay, I can do it. Well, yeah, let's give you back 1 minute of your time, I think. Thank you very much, everybody. If you feel bored anytime, just, go to our repository, look at the drafts that are, not through yet, review them, provide comments, questions. We always love to get more input. And seriously, we prefer the most stupid questions first, right? Because the biggest problem we always have is that everybody who's working on the stuff is an expert and doesn't see anymore what, normal users are asking themselves about it. So never feel shy about it. We'll always appreciate the more stupid, the better the questions, seriously. And otherwise, thank you very much. And hopefully you have a great rest of your week, and hopefully also see you in Vienna then.
See you guys.
Hello, cheers. Can I have a minute? Okay. This.